All right, I think we'll get started. It's 1 o'clock. So I just want to start off by introducing myself. My name is Tim Weber. I'm co-founder of Diverso Energy, geothermal utility company located here in Toronto. Just want to thank everyone for taking the time out of their day and joining us. Uh, we felt this webinar was important. Geothermal, as most of you know, has gotten a lot of traction in the last couple of years, and the primary conversation around geothermal is how it impacts energy modeling, sustainability, the ability to meet carbon targets, TGS, or other municipal green standards. Geothermal is utilized for preferred financing through CMHC, ESG targets. There's a lot of reasons why geothermal is being implemented, and I don't think there's a whole lot of debate anymore, the impact it has on all of those things. However, I think one particularly underserved conversation around geothermal is the execution and the construction. Both from a design and implementation perspective, it's something that doesn't get a lot of attention. It's not always, it's not very interesting. It's complicated. However, from my experience, most of the negativity or the negative experiences around geothermal, it's not its ability to meet the green standards or, achieve carbon targets. And it's not even necessarily in its operation. It's the impact it has on construction, whether that be critical path, complexity, who's responsible for what. It just tends to be a real kind of pinch point during construction. And I think to unpack that a little bit better and help people understand, what are the things you need to consider, what are the solutions for those particular issues? How do you get out in front of it? How do you mitigate it? And what are things that you just have to accept? And at that point, the importance of communication and managing expectations up front. So in order to do that, rather than just sort of talking about this anecdotally or making it a topical discussion, we thought it made sense to bring in two individuals who have a lot of experience with geothermal, who have built multi-residential buildings, many of them integrating geothermal. And I'm sure, no doubt, they'll share, where they've stubbed their toe along the way and things they've learned, their experiences, what to look out for, and, things that you may want to consider. And there we go. So Jennifer Burstein, I've had the pleasure of knowing Jennifer a long time. One of our first projects was with Jennifer and her team. Jennifer is the co-founder and president of NOVI Builds. Jennifer brings a wealth of knowledge, 2 decades of experience as a construction executive in the GTA. Portfolio includes projects like the Chelio condos, Westwood Gardens, Trump International Hotel and Tower. Among others, she holds a bachelor's degree in civil engineering from McMaster and is a Gold Seal certified professional, known for her leadership in managing high-performance teams to ensure successful project outcomes. No doubt Jennifer is going to bring some really very interesting perspective to this conversation. Next, we have Jeff Wilkinson, also co-founder and president of CB Wilkinson Construction. Jeff, I also have known for a long time. Jeff and his team actually was the very first geothermal project we did about 9 years ago. So I've had the pleasure of knowing Jeff and his team for a long time and working, collaborating together on projects. Jeff has been in this probably as long as he can remember. His upbringing on construction sites with his father sparked a lifelong passion for construction and development. He earned a master's degree in construction management in 2006. He has held significant roles at the Rockport Group, Concord Addicts Developments, managing large-scale residential projects like the Parade Condominium. Since joining Wilkinson Construction in 2013, Jeff has been instrumental in increasing the company's scale of work and improving its performance. So kind of as I mentioned earlier, the goals of this webinar is to answer, I think it's about answering questions, but I think more importantly, it's really about addressing concerns and getting out in front of what probably is either misinformation, misconception, and for things that aren't misinformation, as mentioned, we really want to help you understand how to mitigate the challenges and get out in front of them. And, what can you really expect when introducing or implementing geothermal in your project? So first question, Jennifer, we'll start off with you. What key factors must be considered when integrating geothermal into your project? And I think, looking at this maybe more from just a early conversation, what are the things you sort of want to prepare yourself for?
Yeah, absolutely. I mean, geothermal is going to be a decision that you should be making during the early stages of design development for your projects. Oftentimes, there isn't necessarily a CM on board at that point. As a development group, you're engaging with your consultants, your mechanical engineers. Once that CM has been chosen, or maybe there's an internal team performing the work for you, it's really important that you have the geothermal service provider, developer, and builder at the table to have those discussions on the process and how it's going to move forward. The next stage, of course, is getting your trade contractors involved. So whether that be your shoring contractor, your excavation contractor, your demolition contractor, if there's demolition on that particular site, as many people at the table, the smoother the process will go.
Yeah, great. Could not agree more. Jeff, anything you want to add to that?
I think it's good to have not just like letting everyone know, but having buy-in from like the consultants early stages. And I mean, familiarity would be ideal if you're putting your team together, consultant team, but getting them to fully buy in to that process from a design perspective, and then from the construction manager's perspective. It's not just it can't be seen as just an owner contract that's getting handed to the construction manager. They need to be seen as like a design part of the design team, and then fully part of the trade team. That sometimes gets a little confused, I find. So
yeah, I couldn't agree more. One of the things we've learned is projects where we've had challenges is typically when we're dumped in the CM's lap, kind of late stage, and they inherit us rather than being part of the conversation and early days, building that relationship, building the trust, answering the questions, addressing the concerns early on. So when we get into actual construction, there's an existing relationship there. So can't agree more.
Yeah, oftentimes like we set up our trade contracts, you're not even on the list, right? It's a contract that's set up much earlier. So I think the construction guys often don't even think of you guys as a trade, although you have to be part of the sequence.
Yeah.
So, yeah.
Agreed. Great. Jeff, you can start this one off. So remediation, I think, as geothermal we're seeing it more and more in, in-field projects, brownfield, remediation is on, that's a consideration in most of our projects, to some higher degree than others, but what have you seen, and what do you what are the options on the table, I guess, to deal with this?
I guess in my experience so far, it's been I think what I would prefer, it depends if it's an infill site or I guess a kind of a greenfield site, but well, not greenfield if it's contaminated, I guess, but if it's an open site. But if it's an infill site, it works a lot better if the owner can advance their demolition permit, demolish whatever structures are on the site, and then potentially deal with that remediation ahead of the have you guys actually showing up. But we've dealt with it where you have to deal with those spoils if they are contaminated. But ideally, if you can get the demolition done, site cleared, and the geothermal boreholes in after I put the boreholes in after the remediation is done, that's ideal if you can advance it that far. So it's been my experience.
Yeah, Jennifer, any thoughts on that?
Yeah, remediation is a really interesting thing, and the regulations have changed so much over the years as well. I think you have experience with a job site where the first, let's say, 5 feet or 5 meters even of the site were contaminated, and you had to completely remove it. So, the understanding is that you're drilling the bore field from grade, but grade could be at a certain depth if it means early remediation of that site. When you're drilling the bore field, it really, and this doesn't necessarily have to do with remediation needs in particular, but just the spoil removal. what do you do with the material that comes out of 800 feet deep of drilling, right? Back in the day, lessons learned, of course, we would stockpile it if we had space on site. But that could be problematic. You then end up having to blend it in with your bulk excavation. Often it doesn't dry in time and it's a big sloppy mess. And so I think more so nowadays you're seeing trucking needs at the early stage where you're removing the spoils and binning them and then trucking them off site even before your excavator shows up at the site for bulk excavation.
Yeah, I think you're right. And you know, you can have a great plan in place. What we're finding more and more now is the environmental engineers are more involved. And at the end of the day, whatever plan we come up with as a team still needs their sign off. And ultimately they're really driving what that solution is, whether it's double walled casing or, you know, stockpiling it in bins and taking it to a separate site. But I think kind of back to the first question, it's really about understanding all of this in advance, and it's not something we're figuring out on the fly first day of construction. So
yeah, it's difficult too because developers they'll often have like borehole examples of where there may be some contamination, but it's an unknown factor really until you start excavating and exposing that material. So there's the need for constant testing to prove the contamination levels of the spoils that are removed as well. So having your environmental engineers on site and inspections continuously is important.
yeah, and I think
sorry, Tim, I just going to say they need to understand the sequence. Like that environmental engineer needs to understand the sequence because they often, well, many have not dealt with geothermal drilling.
No, and I think that fortunately, you know, there's enough projects now and information to educate the engineer and ultimately get their sign off on a solution that's reasonable for everyone. And fortunately, you know, the solutions are all over the map, but to date, from my experience, I'm not aware of a project that could not move forward or you know, environmental may be a consideration, but it's never been a showstopper. So it's great. Back to you, Jennifer. So what measures can be taken to ensure that geothermal does not impact the start date of other contractors? I know that's a bit of a open-ended, loaded question, but let's turn this more into discussion than maybe an absolute answer.
Sure. I mean, it's all very site specific, right? When you're looking at a site, you know, the example you have on the screen right now, it's a little bit of a larger site. You know, early stage coordination is important, of course, but you could take a look at this site and think, all right, well, the bore field can be drilled on this site. It can, you know, concurrently with the shoring contractor with the perimeter shoring. And we've had experience before where we've had to demolish buildings on a site, on quite a large site. And so we were able to design the bore field around those buildings. So we were able to demolish, drill the bore field, and do the perimeter shoring at the same time. If you're on a very small stamp site, you know, let's say a typical site downtown Toronto, you may be in a position where you're dedicating your first 3 months of early works to geothermal drilling alone before your next contractor can start their activities.
Yeah, Jeff, any thoughts on this?
Well, in an ideal world, if you can place the bore field outside of the footprint of the building, that'd be amazing. I know that's rare.
Yeah.
But yeah, I'm on board with totally trying to get that bore field in as soon as you can, not to disturb the full construction sequence. But if that's not possible, yeah, same comments as Jennifer. Yeah.
So here, I'll turn the tables on you since this is a geothermal provider and CM conversation. I think for us, you know, you mentioned getting the bore field in as quickly as possible. What we've found a lot of times that relationship and collaboration with the CM is so critical because in order for us to drill quickly, we need a platform that's stable. And if the platform for some reason is deteriorating, whether it's due to weather or you know, geotechnical conditions that weren't conceived, we rely on the CM to make sure that things get moved out of our way, whether it's snow removal or if there's items that are stored on site for staging and that things are moved around to make sure that the drilling is not interrupted. And quite often that is a little bit of codependency between us and the CM. And that's where that relationship, I think, is so key.
Yeah, and it's also important to consider some of the other measures that need to be taken into consideration, right? Water, you're going to need water at certain pressures on the site in order to perform your drilling. So you're relying on the CM to have that readily available for you, coordinated through whatever means they have to. Like you said, that shoring platform, if you can come in and build a full shoring platform in advance for the shoring activities and the geothermal driller uses that to drill their bore field, all the better.
Yeah, we've had, multiple projects where corners are cut on the platform and, we're trying to get off site quickly and everybody, the clock's ticking and we're sinking up to our axles in mud, having to drag rigs around. That's not the most effective way for us to get in and out quickly. So, all of those things add up.
Yeah, another thing we didn't touch on was the sequence of the activities and geothermal drilling being considered early works. So, is Diverso the constructor at the beginning of a project? Are they responsible for the notice of project until their activities are done and then it gets handed off to the CM thereafter? Or is the CM on the notice of project from day one and coordinating all those activities? So just other things to consider.
Yeah, and we've done both, and it's very project specific, as you mentioned earlier, Jennifer. If there's other trades on site at the same time as geothermal, it probably doesn't make sense for the geothermal provider to pull that NOP if it's done sequentially. And I think the geothermal provider would kind of lean on the CM to help with that process. But either way, those are all things that need to be discussed up front.
Tim, I would just say, you're asking here does not impact the start date of other contractors. I think at least some of the scale projects that we've done, it can be challenging to overlap. We had that on our Manderley project. So not a small project, but we struggled in some cases to overlap contractors. So I guess again, there needs to be scheduling and sequencing and buy-in from those contractors, because if you tell your under slab services contractor he's going to be working at the same time as you're doing your laterals, that doesn't just go so well unless it's pre-planned, because they don't want to work together. So anyways, that's all I would say to that. I think it's like reserving time for geothermal. Like, you've got to have the activities clearly in your schedule, and get the buy-in from the trades. Yeah,
I think there's absolutely an opportunity for overlap. One of the things we've learned is no good deed goes unpunished. And we've kind of learned, especially with shoring, how much overlap can there be? And if you overcommit to that, it's a challenge for everyone's upset. We're tripping over each other. It's just too small of a dance floor sometime for that many. And you have to think about all the little things, the staging areas, the ability to move stuff around, trucks coming in and off the site, because of now everything's going into bins. So those roll-off trucks have to be able to come in and out of the site every day. So the less overlap, the better. And what we try to do is if shoring is going to start on the kind of north, east corner, we'll start our drilling there and work away from that corner rather than working towards it. So if the drilling's delayed by a couple of days, there's no reason why, there's one rig left, most of the stage, the pipe's gone, everything's gone. There's no reason why a shoring contractor can't mobilize and get started while we're finishing up on the other side of the site. But that's where that pre-planning kind of comes into place, right?
Well, where it gets hairy too is it down in the pit, and even though our Manderley site was not a small site, our footings were huge. Our spread footings were huge. So we are dealing with a very tight site when you actually come down to how much space there is to work between footings. So it really depends on how much space you have to work with.
Yeah, and if the project's under a tight schedule, sometimes we've noticed there's a lot of forming contractors on site. It's almost like there's a busload that come in and they're moving very quick and we're racing against the clock to stay ahead of them. It's why our tie-in crews work 12 hours a day, because they're under tremendous. That's, from our experience down in the pit, will have the biggest impact on schedule and probably where the most conflict happens. If there's a scheduling conflict, is it possible for these activities to overlap? Jeff, if you want to start us off with that one.
There is a scheduling conflict, is it? I guess it is possible. It is possible for sure. I think it depends so much on the site and the site and the actual design of that site. So Yes, we have done it together, Tim. We've overlapped activities at the bore field stage and the lateral stage. But I think, yeah, I think it could have been planned out better when we're doing that overlap and had more conversations, probably pre meetings with trades on how that overlap is going to work. We like another example for Manderley was, you know, we put our catch basins, like all our catch basins in first. Then we had the under slab services guy go away for a few days while you guys did the bulk of your work, and then we had them come back. So I think they are overlapping, but I just kind of caution like banking on putting the same different trades in the same spaces, because that's definitely, you'll get conflict in that situation. So
Yeah, I mean, you've got a lot of experience with this, both, you know, some of your sites were large where we were able to do this with, but that, I'd say those are becoming more the outliers than the norm. So
yeah, I mean, we've talked about the overlap of those early activities with the bore field being drilled, and Jeff mentioned the horizontal tie-ins, and that's often with spread footings. That's often done with your under slab drainage contractor, right? And they'll have more unique specifications on their slopes that are required. And you guys, if I'm not wrong, have a little bit more flexibility, right, with your horizontals, as far as those tie-ins are concerned. So following after that under slab drainage contractor, but coordinating, of course, the locations of where you guys are working is really critical. The one thing we didn't talk about, which I often get questioned, is the next stage of activities, which is the mechanical tie-ins. So, you know, I've had developers ask me before, is it possible to have a different mechanical crew on site for the geothermal work that's required? And the answer is yes. You know, it's ideal, of course, if your base building mechanical contractor does the work, but if not, I know you guys have a lot of really great relationships, Tim, and even perform some of this work in-house. Your geothermal bore field is under the ground, but your room is usually on the lowest P level. And so it is very much so out of the way of your base building mechanical trade contractor.
yeah, it's a fair point. I think at the end of the day, you know, we have a mechanical contractor we've been working with for 10 years, and you know, it's consistent and it works, and that's kind of our go-to. However, if there's a situation where it's important to use the on-site contractor, it's Victaulic piping and pumps and controls. It's not, there's nothing unique about the geothermal mechanical system. It's just an extension of what's already in the building. So, Jennifer, what advice would you give when it comes to integrating and sequencing during the tie-in period? I think we've covered some of this, but maybe let's do a little deeper dive into this, because this I think is one of probably the most least understood and one of the areas that creates the most contention on most projects.
Yeah, and we've had some lessons learned with this. You know, you can speak to this as well for me, but at one point we had a spill out from a footing pour, let's say, and it damaged the horizontal tie-ins. So you guys are taking care, once you're completed with those horizontals, you're adding your layer of gravel for protection on top of that pipe. And so those are the small, like, minutia type details that need to be taken care of to ensure that there isn't damage of that system.
Yeah, Jeff, anything to add to that?
yeah, I would say again, because Manderley is most fresh in my mind. One of the things that we had there is it was kind of a corkscrew parking garage. And I think, you know, the ones that I'd done before, all the geothermal projects that we'd done before, I don't think we'd ever had a corkscrew foundation like that. And so the elevations like really became really important. Your cutoff elevations, also the structural engineer understanding your lateral elevations and how that relates to the footings and their so we don't undermine the footings. And again, Manderley, we didn't have a lot of space, so you're having to run your laterals pretty close, and so yeah, I would say like the whole team has to understand elevations very carefully, the architect and the structural engineer, and the mechanical engineer for the under slab services. So that I think needs a lot of attention with that type of foundation.
Yeah, and it's interesting you say that. it's one of the biggest key points that we focus on at the beginning of design stage is that geodetic elevation of the lowest level of foundation, because when Diverso is doing their vertical drilling, they need to cut and cap those pipes right space, right, in order to expose them so that they can do the horizontal tie-ins. And so if those are out of level to where that foundation level ends up being, it could be more problematic.
Yeah, I think there's a bit of a theme here between the three of us, and that's the term lessons learned. And I think, you know, when I get asked the question, what's the new innovation in geothermal, or how's there been innovation in the last 5 years? The reality is geothermal is water, dirt, and plastic pipes. There's not a lot of innovation in the technology. The innovation has come through the process. And, you know, Jennifer, you mentioned that concrete being poured on our lateral tie-ins. Well, that was a certain, you know, we dealt with it and we sorted it out. It wasn't a big deal, but that changed our process. Now, when we pressure test, when we're doing our lateral tie-ins between pour breaks, before we move to the next pour break, we don't leave that until it's pressure tested, gravel's on top, it's protected. Because what happened there is we left it unprotected, it got damaged, nobody said anything, and we had to deal with it after the building was up, which is doable, but less than ideal. So I think every time, you know, we see something that's a problem, we try to integrate that into a new process. You know, easier said than done. And I think this is helpful for people that are new to geothermal and are considering. And I think the message there from the team, from all of us, is fortunately for you, trailblazers like Jeff and Jennifer have, you know, helped folks like us learn a lot of these lessons. And you're kind of coming into this at a pretty good time, where I'm not saying everything's fully baked, but those processes are a lot different now than they were probably even 2 or 3 years ago. So during the tie-in process, what key differences have you seen between raft slab and spread footing? So I think this is a big one now for obvious reasons, you know, with the recent changes, especially in the city of Toronto with dewatering, seeing a lot more, not just raft slabs, but bathtub raft slabs. So I think it's important to identify the difference between a regular raft and a bathtub raft. But Jeff, if you want to take a swing at this one.
I guess, you know, first I would say that we haven't done a geothermal project with a raft slab, but theoretically, I think it's simpler. So I think spread footings create space issues. I think a raft slab, and the way it's been explained to me, and you know, where you bring your laterals all up in one spot, to me, that I think it's actually a far simpler process. So that's my opinion, but I defer to Jennifer if she's done that before.
Yeah, it's I had a developer once tell me that they can't use geothermal technology on their projects because they had to bathtub there and have a raft slab that was bathtubbed. And it's interesting because it's absolutely doable. It's just a completely different process. You know, with traditional spread footings, your boreholes are designed in between those footings. You then connect all of those through horizontal tie-ins, which connects down into the lowest level P, the lowest P level into your mechanical geothermal space. With a raft slab, and in particular a raft slab that has that is bathtubbed, you don't want to have any penetrations, of course, in that interstitial space. And so when Diverso comes to do their horizontals, they actually have this, you know, the site to themselves. They're connecting all of their horizontals and they're bringing that up through, like you mentioned, outside of the raft. And so there's a bit of coordination in advance. I would say if you can give the geothermal horizontal line a bit of space, and I think, Tim, it's like 8 inches, right? It's not an awful lot of space, but if you can jog your shoring wall by 8 inches, all the better. If you can't, you can get your shoring contractor to scrape down that shoring wall to give that excess space outside of the foundation wall. So you're bringing your horizontals up between your shoring and foundation wall, and you're bringing that up to likely whatever is above that water line. So probably your P1 level where you'll have your geothermal mechanical room.
Yeah, exactly. And You know, that sounds simple enough. To your point, Jeff, in some ways it is simpler. Probably, well, they both require a tremendous amount of coordination, just different coordination. I think one thing to consider with the raft slab, we're down there, we have to do our entire tie-in. So if it's 120 holes, we're doing all 120 holes before you can pour that raft. So the impact on the schedule may be greater because with spread footings, at least all we need to do is that first pour break, and then we kind of work, so you're chasing us around the site. So it might be a 2-week impact on your schedule. Now, that being said, when we're doing with spread footings, there's a lot of activity in that site and we're crowded and it's not nearly as efficient for us to move quickly. Whereas in the case of a raft slab, we have the entire site to ourselves. We can hit it hard. It's much more efficient. So the actual time per hole for tie-in is a lot less, but we have to do all of them. So there would be a greater impact on the schedule. It's probably more like at least 4 weeks, maybe even 5, depending on the size of the site or the number of holes. But I think the key takeaway on this one is the reason why, Jennifer, somebody said, you know, you can't do geothermal in the bathtub raft slab. It's really about I think the go-to is, well, you have to penetrate the raft. It's about penetrating that waterproofing, and that's a non-starter, and it would be a non-starter for us too. And I think the solution that you described is really a way of getting around that. And when you wrap your head around that, if we're not penetrating that waterproofing, or if we are, it's probably above the water table, or at the very least, a much lower static pressure. 2, it's into a controlled environment. It's not, you know, 100 penetrations into that interstitial space, which is hugely problematic if there's a leak. If there is a leak, it's in a controlled environment in the mechanical room, it can be resolved. So far less risky. So, you know, this comes up a lot, you know, is it important for a geothermal contractor to provide operations in-house? And, you know, I think, you know, the context behind this question really ties into everything we've talked about in the last 6 questions. It's, you know, everything you guys described is so important. The only way that happens, though, is the geothermal contractor, like anything else, has full control over what happens. And one of the lessons we've learned, especially tie-in. Tie-in is the first thing we brought in-house. I mean, engineering was always in-house because we feel that is the most important thing. Second would be tie-in, because that's where we always had the most conflict. So we decided we had to vertically integrate the tie-in. So just kind of want to get your thoughts on that as a CM. You know, where do you see the pros and cons of vertical integration versus not? Question 7, odd number. That's you, Jennifer.
Listen, I love the vertical integration in any form, right? I mean, if we can hire a trade contractor that performs 2 or 3 activities, then all the better. It makes it easier for coordination. So, you know, I'd second what you said about engineering being the most important thing that you guys do in-house. On any job, you're going to have likely 3 different engineers analyzing the requirements of this site between your mechanical, your energy modeler, and then your geothermal service provider. Having that in-house is critical. The drilling itself, I mean, if you're not drilling with your own in-house team, you're relying on a subcontractor, which can be fine, but also can, you know, cause scheduling conflicts. And if you're not in full control of their activities, those horizontal tie-ins are, you know, just the same as the drilling, and then mechanical services and work. And then to finish, really, the operations of the system in the long term, which is incredibly critical, because the last thing you want to do is design this wonderful system and hand it over to, let's say, an inexperienced geothermal provider to manage it in, you know, in perpetuity.
Yeah, Jeff, what are your thoughts on that?
I think because you guys have kind of the unique place of being a designer and an actual, like, I guess almost like a trade contractor. So you're designing and you're building as part of the team. I think that, like, you at least I can speak to, you know, you guys and our experience with Diverso, you know, having you and Sergio part of the design, but then also being those guys that we can talk to who are doing the work on site. Not physically the work on site, but I can see, but it's Diverso taking care of it. So I think that's that's pretty important for this specifically, just because design relates so closely with construction. In your case, you're not a consultant, you're not necessarily a trade contractor, you're somewhere in between. So yeah, I think there's a big advantage to how you guys are set up with
Well,
doing the work
you
in-house.
just brought up kind of an interesting, you just said we're not really this and we're not really that. And that's kind of been our problem from day one, is nobody really knows what to do with us, because with our utility model, we're not really a bank, but we're investing equity in the project. We're on site, but we're not really a contractor, but yet we kind of are, but working directly with the owner. And, as we've evolved as a company, what we've realized, and I'd say we knew this kind of early days, for you to operate a system effectively, you have to be the one designing it, because you can't inherit something someone else designed, but now you're responsible for operating it. What if you don't have the levers in place? It's cooling dominant, all of those things. You need to understand this living, breathing entity that you've inherited for 30 years. But you also want to make sure that if you're designing something, if you're building something, you kind of want to be involved in the design, because now whatever that designer's doing, you have to be able to build. So it's all this kind of, there's a bit of codependency between all three stages: preliminary design, execution, and then post-occupancy operation of the system. I think if I were to rank them in order, it'd be design number 1, tie-in number 2, and drilling number 3. And for us, the drilling integration, which we have now, we did that last because I'm not saying drilling isn't important, but it's relatively simple. You're drilling holes. We vertically integrated drilling more to do with our ability to scale and access to resources than it was anything else. It is nice we do find our speed and the quality control has gone up a little bit, but that wasn't the main reason. It was really about access to resources. But the tie-in and engineering, I think, that's the difference between a positive and negative experience for most clients. Okay. So again, another somewhat loaded question, and also a lot of what ifs on this one. I'm also noticing the money is American, which is interesting, but what are the potential financial ramifications if geothermal impacts your critical path? And obviously referring to negatively impacts your critical path. And I suppose that depends on where that impact is, which probably leads us back to the significance of tie-in. But Jeff, what's your experience in regards to this?
I think if it's scheduled, you're planning for it and it's not a surprise, then there's really not I don't think there would be much of an issue for an owner as long as it's planned. So if you are delaying, if you delay your work at your tie-ins, you're playing catch up for the rest of the project. But if it's properly scheduled and everyone's on board with geothermal and we all have activities in the schedule, then I don't see I don't see what the financial ramifications would be. That's straightforward. And I would just say to add to that, on the back end, I think, based on my experience, it's very simple. Once those laterals are in, it's surprisingly simple to get the geothermal borefeld working at that late stage. So there's no concern on my mind down the road. It's really just that early stage and mostly the tie-ins. So, but if it's scheduled, I don't see how that would be there'd be any ramifications. Yeah.
Oh, Jennifer, you've seen this from both a builder and a developer. What are your thoughts?
Yeah, I think from the developer's end, the bulk of the work that's done in geo is in the early work stage, which is often in advance of the construction loan and the interest that starts to incur, right? So it is better. It's never good to have a delay on a project, but it is better to have a delay at the beginning of the project when you've only incurred a small amount of cost, as opposed to delay at the end of the project when you're carrying sort of that full capacity of your construction loan and interest levels are really high right now. So, I think this question can be answered with any schedule impact, not necessarily just geo, but a schedule impact predominantly towards the end of the project is going to have a critical impact on the overall profitability of the project. And it could delay the occupancy dates that you were expecting for interim occupancies on a condo, let's say, or, final registration of the building and closing. So like Jeff said, it's really important to get everything coordinated, sorted out before you've got your first boots on the ground.
Yeah, I agree. I think where we've had, you know, uncomfortable conversations, it's not so much around the schedule impact, it's about a schedule impact that wasn't predicted. And I think, you know, we've done projects with 6, even 8 levels of underground. 8 levels of underground, as you can imagine, by the time we're in the pit doing tie-in, there's been tens of millions of dollars have been spent on that project, which, you know, 4 years ago was a factor. To your point, Jennifer, with interest rates the way they are now, you know, the debt service on probably $20 million land loan and another 30 million of shoring and excavating, 1 month is not insignificant, and it does not go unnoticed. So I think, you know, managing those, and I think what we're finding is we're trying to be as truthful and realistic as possible. It's not so much about the actual time, it's making sure that it's built into that Gantt chart, it's built into the financial model, and it's less about the actual numbers, it is about surprises. So in other words, don't oversell is what I'm trying to say. So I think we'll open it up now for questions, if there is any. Can you discuss tax credits? Yeah. I can take a swing at that unless one of you wants to take lead.
It's all yours.
Yeah, I think the simple answer there, you know, that's something that's been talked about for months. It just went through the legislature last week. We're working very closely. Our CFO is working with KPMG, the accounting firm, to unpack that. As you can imagine, it's a government program. There's a lot of ambiguity, a lot of uncertainty around what qualifies and what you need to do. So I think the simple answer is there definitely is an ITC, investment tax credit. What's included? I think the geothermal portion is pretty clear. What's less clear is the building mechanical system, what's included in that and how much will you get and what's required. How do you address issues with long-term corrosion of the below slab piping? I want me to take that one again. So that's an easy one, but go ahead, Jennifer, if you want to.
No, I mean, I think this is probably more up your alley, but I would just say, you know, that question did come up years ago when we first started. I think you gave us quite a bit of certainty on the longevity and warranty of the materials that you're using below grade. The other thing that's unique, I think, is that you are designing your bore field often with isolation. So if there is a problem in one area, it can be isolated from the rest of the bore field. So it's not a, you know, a complete failure of the system over time. You're just identifying where, you know, the issue has come up for whatever reason, and you can isolate that out from the rest of the system.
Yeah, which unfortunately you've experienced firsthand. So
yeah, and I'll say not in corrosion, not in
corrosion.
Not in the corrosion, more so in the blockage of the pipes, which can
concrete, yeah, concrete induced leak. But I think the simple answer there is it's high density polyethylene pipe. It's got probably 1,000-year lifespan. It does not break down. The only thing that breaks it down is UV rays, which obviously under the building, it's not being exposed to. It's the same material and fusion process that Enbridge uses for their gas lines, which obviously are not a 30, 40-year asset. They're a 100-year asset. So yeah, the system does not break down. Regarding the site remediation, if you have an RSC, does the borehole material still get constantly tested during drilling? I am not an engineer. I would probably have to defer to my team on that. To my understanding, the answer is no, unless Jeff or Jennifer have an idea on that, but I do not to my understanding, it's not required.
I think the answer would be no. Again, I don't know definitively, but I can say if you have an RFC on a site, then you don't need to test for the rest of your bulk excavation. So I don't believe that there'd be the need to test for the individual boreholes unless you knew that there was unique locations of contamination.
Yeah, that makes sense. How does open loop versus closed loop affect scheduling early in the project? I understand approvals can vary between the two. construction. So two very different technologies, just to, not to go too far down this rabbit hole, but open loop is essentially a system where you are drilling a well or a series of wells and you're pulling water out of an aquifer, and that water goes into the building through some type of mechanical system, chiller, heat pumps. Probably there'd be a sacrificial heat exchanger in between, and then it gets rejected back into that same aquifer. So there's an extraction well and a rejection well. Not a very common practice in Ontario. There's some systems in places like Waterloo where, because of their wellhead protection programs, it's very difficult to do closed loop. And for some reason, they're okay with open loop. So there's a few here, but in Toronto, I'm not aware of any open loop systems of any significant size. Pros and cons, open loop may be a little bit less expensive. However, from my experience prior to Diverso, spent a lot of time in the US where there's a lot more standing column wells, open loop systems in the Northeast. And you're kind of subject to Mother Nature, the quality of the water, of the aquifers, the quantity of water from those aquifers can change. So it's very unpredictable. It's very hard to design. We as a company who owns these assets and guarantees them for 30 years, it's not a technology we're willing to look at, simply not because it doesn't work, it's just because it's too unpredictable to guarantee it for the long term.
And I'll say in all of our projects that we've done, and I think likewise for you, Jeff, it's all closed loop.
Can you please provide some idea about the cost of geothermal? We heard ROI is more than 20 years. Yeah, that's a great question. I mean, obviously, the cost, it's a little bit of how long is a string, depends on the size of the building, but on a 300 unit building, it's probably going to be somewhere between anywhere from $2.5 to $3.5 million all in, approximately. ROI is a whole other conversation. I think the problem with ROI is, first you have to start with the baseline, and I think what's happened now is the baseline has changed. 5 years ago, when you didn't have to do geothermal, ROI was just based on operational savings. Natural gas saved, electricity saved, water, some maintenance, repairs. If it's a condo, the capital reserve looks different because you don't have a cooling tower that has to be replaced. So that was, relatively objective savings that you could figure out, and it's 10 to 15 years maybe is the payback, or it's an 8 to 12% ROI. However, if you're building a building now and you have to, adhere to the new Toronto Green Standard, or if you're looking at CMHC and your option instead of geothermal, it's triple pane windows and punched glass or punched windows, and your makeup air now requires a heat recovery wheel and half a dozen other technologies. Well, you could have $2-3 million worth of technologies versus a $2 or $3 million geothermal. And now the question is, do those other technologies provide the same operational savings as geothermal? So it's not really about payback anymore. It's what's the most simplest, cost-effective way of meeting these new targets during construction. And I think there's no payback on smaller windows, really. If anything, I think if you ask somebody in real estate, a VP of development, they don't want small windows. It's harder to sell, harder to lease. And so that would be considered a negative, not a positive. So, I mean, Jennifer, Jeff, get your thoughts on that, but I think that conversation has changed significantly in the last 2 years.
Yeah,
I'll jump in. I think just simple terms, Tim. We involved you guys. This is probably 7-8 years ago when we did Brickhouse Gate condos. We presented the option to the owner. You guys fit your model into their condo fees that had already been published. So for them, there was no financial impact. That's a condo scenario. So that's and just to answer another question, that project has been running for 6 or 7 years, I think at least, Tim, and there's been the feedback has been fine on the system. So no, they don't even really know it's there. So that's what I would say to that.
Yeah, I think when you look at ROI, if there's no investment, then is it even worth talking about the R? Like, there's no return if there's no I. And I think with the utility model, by turning that capital expenditure into an operational expenditure, all that really matters is that are those fees in line with the savings? You don't want to create a liability. So as long as it's relatively close, it's a really painless way for a developer to integrate it without it impacting their pro forma. So I've heard using geo can increase building side equipment costs, requiring more efficient heat pumps. Is there a simple way to quantify this impact? Yeah, and I think, what, you guys go ahead. If you have an idea on that, I'll answer that later. But, what is your perspective on how does geothermal impact the mechanical design or mechanical cost?
Yeah, we've opted in the past to go with more efficient heat pumps, which can be a slightly bit more costly, but then there's so many other offsets. We no longer require a cooling tower. We no longer require a chiller. So it's a balancing act, and it's certainly not, we've never looked at it, and we've done 11 towers in the last 8 years or so. We've never looked at it in a way that, the end of this question is just avoid it and go traditional. There's no sense in going back to traditional because there may be a few offset costs. It's, you need to look at that investment over the long term and realize that you're building a building that's going to be occupied very close to when requirements are there to, reduce natural gas in our buildings or eliminate it altogether. And so geo is really the right direction to take.
Yeah, I guess my experience has been, Tim, I think we've had this conversation a few times. If you're in a scenario where maybe you're building a building with a 2-pipe fan coil system, I don't know. There may be, I don't know if there would be additional costs to if you put it tying in geothermal. In our cases, we've done it on projects where we're using the water source heat pumps or water source VRF, and there has been zero difference in the building costs. We're just tying into a different system, so never changed the building system at all from that perspective. Equipment.
Yeah, I think we've learned a lot, and I for me being on the front end of our sales team, I think our approach now is very different than it was 5 years ago. We try to be much more upfront and much more pragmatic about that financial impact. Because yes, you're removing the cooling tower and maybe a boiler. What I've learned is the financial impact of that is a lot less significant than what I would have thought 5 years ago. And that's just getting feedback from clients. And I think the problem is, yes, you're eliminating some major pieces of equipment, but there's a whole bunch of other additional costs, and they all may be minor, but they add up. So the example of the increased efficiency in heat pumps, I don't think it's necessarily about increased efficiency, but you do need to go to extended range, and that's about $150 a heat pump. Not material, but it's a cost. Creating that platforms, maybe some additional cost there, putting that platform in advance of our drilling, cleaning it up afterwards. The heat exchangers and additional cost. The makeup air might look a little bit different now if it's tied into the geothermal versus a conventional. And the other issue, and this maybe will change as trades get a little bit more familiar with geothermal going in buildings, but eliminating cooling towers, it's a classic trade scenario. You're getting 50, 60, maybe 70 cents on the dollar. So you're not, most cases, probably not getting the full value of the elimination of equipment, but you're definitely getting the full value of the increase in equipment. So that doesn't always add up either. But I think with the utility model, I would argue it's probably a wash. At least that's what we tell clients. Go into this assuming no construction savings. It's cost neutral. If you can gain a little bit of GFA, or if there's some height issues, or maybe getting rid of that cooling tower allows the architect some creativity on the roof, I don't like to use that as a base case. I think those are things that get uncovered throughout the design that are a bonus. Is this technology feasible to use in mid to low rise developments, ranging from 35 to 80? So Jennifer, Jeff, what do you think on that?
Well, I don't have experience with projects that are that size, but I want to say absolutely feasible on those projects. I mean, geothermal is done in single family homes as well. So there's no reason why it can't be right sized engineering wise. It likely just means that you've got a lot less of a bore field to drill to provide the capacity that's required for only 80 dwelling units or 35.
We did a project with 78 units, Tim. And we're involved with a project right now that's 50 units. So yeah, I think it is depending on, I mean, the model that you kind of, you have to do.
Yeah, I think what changes with that, like especially a 35, 40 unit building, it's not about the feasibility geothermal, it's more what's the baseline system? Because with a 35 unit building, maybe the baseline is splits, air source heat pumps. So then, whereas on a 200 unit building, it's probably a central plant, either air handlers or distributed heat pumps. So geothermal becomes a bit of a bolt on to that system. It's pretty straightforward. Whereas on a 30 unit building, the question I always ask is, what is your mechanical engineer proposing? Because if putting in geothermal and you have to upgrade your mechanical, then it may be less feasible. And I think air source is a viable option on a 35 unit building, whereas on a 20-story building, it's probably not even an option on the table, right? So there's probably a few more considerations, but does it work? Absolutely. To Jennifer's point, it's going into single family homes. So geothermal can be applied anywhere. It's just the economics might look a little different.
Yeah, we completed a 30 unit project on River Street, which is geothermal. It wasn't with Diverso, but that was a rental project. They were going to own the bore field, so they made it work, I guess.
Yeah, it works fine.
Yeah.
With ground source heating, do you still recommend redundant gas heating capacity? If so, a rough guide as to percentage of overall capacity, Southern Ontario climate zone. Want me to take a swing at that one?
That's yours, Tim.
All right. Yeah,
That's yours.
it's great. It's a great question. It's the topic of constant debate. I think first thing to understand, believe it or not, multi-residential buildings in Southern Ontario are very much cooling dominant from a geothermal bore field perspective. So in other words, there's more heat going into the ground in the summer than there is coming out in the winter. So our bigger issue isn't adding heat through a gas boiler, it's how are we getting rid of heat? And there's two things that are contributing to this, making it even more cooling dominant. One is the obvious climate change. Winters are getting milder, summers are getting hotter. And as buildings get more efficient, that actually increases that imbalance because increased efficiencies in the envelope have more of an impact on the heating load than cooling. Cooling's mostly internal. So it's really about rejecting heat, and that's often done through domestic hot water preheat in the summer through the bore field. Passive preheat is a great way to dump heat. On very tall buildings, it's done through snow melt, active or passive snow melt. When there is a gas boiler injecting heat, that's usually just for year one. That's a whole other design consideration to avoid glycol. But once you get into year 2 or 3 and that system starts to stabilize, it's now more an issue of rejecting heat than it is inserting heat.
Tim, again, we have a little bit of experience, on 5 projects we've done. I think I just caution like a design team into that redundancy conversation, like how much redundancy is really required. That's where I think you guys have been helpful. And Sergio in particular has been helpful because there are mechanical engineers that insist on total redundancy, and then you may as well not do the geothermal if that's the approach. So I really think the mechanical engineer has to either believe it or not. And if there's a bit of redundancy, maybe that's good. And you guys have ways of building in redundancy, but we've priced jobs where the mechanical engineer wants to do both, and it's never going to be feasible. So we've finished 5 buildings together, 5 buildings in geothermal. There's no problems with the operations. They have no redundancy on those buildings. So I just challenge that perspective a bit every time we have the process, because we've gone through it on every single project we've been involved with. They always redundancy is a need, it seems, and it's not, I don't think. But
yeah, Jeff, that's great. And the challenge with redundancy design too is that it then puts the building operators at risk in the future if they're relying on that redundancy and they may not even know that they're using that natural gas. Then you're not making the most use of that bore field, and you're really paying twice. If you're on a utility model, you're paying to 2 different utilities for something that one can the bore field can handle on its own. So.
Well, and you're also deteriorating that, as a geothermal operator, our biggest challenge is when those redundancies are forced, they actually create more of a liability down the road, because now there's an opportunity to reject too much heat or to add too much heat. And I think, our priority on day one is meeting with the mechanical engineer and getting them to trust us. There's confidence in our design, our ability, our track record, proof of concept. To your point, Jeff, if they're not comfortable, it's belts and suspenders, and belts and suspenders are expensive. And I would argue they're also a long-term liability. So it's really about establishing that confidence with the M&E team. It's great. Well, it's 2:03. I'll just do one more quick question because there's a good one here that I think is important. Is it better to supply fluid to small individual heat pumps, so distributed heat pumps, or is it have a central heat pump providing hot and chilled water to fan coils? So there's no real right or wrong answer to this one. It's two different solutions that get executed all the time. I don't know, Jeff or Jennifer, if you have an opinion on that, one way or the other, but I think it's important to identify that there is no right or wrong to that. I think that's one of the misconceptions of geothermal early days as well. If you're doing geothermal, you have to have heat pumps in the suites. And as much as that is the most common solution for some, I think often just for practical reasons, we've done water source VRF. Jeff, you have a lot of familiarity with that. We've done 2-pipe fan coil, 4-pipe fan coil, and distributed heat pumps. We're relatively agnostic as to which distribution. Geothermal works the same, and it really comes down to which one's more practical for the building, preference with the mechanical engineer, and a preference for the building owner.
From my experience, it comes down to, I think at least in my experience, it comes down to scale. We did complete a building that is exactly what is in that question there. Fluid to small heat pumps, no central kind of heat exchanger. So I think there would be a lot of piping if you wanted to do that on a larger scale. So for us, it worked well on the small scale project, but I don't think it would be efficient on a larger scale building, that approach.
Yeah, it's really, it's building specific. I think the most important answer there, that's not a geothermal discussion. For geothermal to be driving the mechanical design, from my perspective, is the tail wagging the dog. It doesn't make sense. You tell us what is the preference in the building, and we design bore field accordingly. Well, I think we'll end there. It's 2:05. For those of you that are still on, thank you so much. This has been great. Jennifer, Jeff, thank you for taking your time and sharing your experience, your wisdom, your insight. This has been excellent. So thank you.
Yeah, thanks for having us. It was a great conversation.
Yeah, everyone enjoy the rest of your day. Thank you.
Yeah, thanks.